Okay, so we'll start a new topic. That's electrochemistry. So today we'll study about the electrochemical cells and the electrodes. Okay, so we'll be seeing about what is this galvanic cell. We'll be seeing about this electrolytic cell. We'll be seeing the redox couple of cell, electrode potential, standard electrode potential, cell potential, and what is the relation between delta Z and E cell. So these are the major things that we'll discuss today. So electrochemistry, it is the area of chemistry that is concerned with interconnection of chemical energy and electrical energy. So how you are converting the energies between the chemical and the electrical, or how the energy exchange happening between the chemical and electrical. So that branch is electrochemistry. So your electrochemical cell, it is the device that converts this electrical energy into chemical energy, or it will convert back the chemical energy into electrical energy, that you know. Okay, first suppose you can take a battery. Battery is a electrochemical cell. Okay, so remember here this battery takes the energy that released by the spontaneous chemical reaction. Remember, this battery takes the energy released by spontaneous reaction. Okay, so this will be helpful for producing the electricity. Okay, so in this battery, the spontaneous chemical reaction will happen. That means without you putting any energy or without you investing anything, you will directly get the energy. Okay, so this produce electricity. Remember, we'll be seeing in detail how these things will happen. Okay, so electrochemical cell. So when we talk about the electrochemical cell, they were majorly two different types. One is the galvanic cell. The other one, it is the electrolytic cell. We'll see what is the difference between this galvanic cell and electrolytic cell. So see this galvanic cell. So this galvanic cell, it is also known as the voltaic cell. Remember, it is also known as the voltaic cell. So what is this? It is the fundamental electrochemical cell that converts the chemical energy into electrical energy. Okay, but this conversion of the chemical energy into electrical energy will happen through spontaneous reaction. Remember, that too the redox reaction. Okay, so when we are talking about the reactions here, that is redox reaction. Shrika, tell me what is redox reaction?
Sir, I don't remember, sir.
Sharon, you tell me.
Yes, sir, I remember oxidation reduction.
Google చేసిన చాలేరా?
No, sir.
Sharon,
Yes, sir.
what is redox reaction?
Okay.
Huh? Remember, this is very important when we see about the galvanic cell. So this galvanic cell, also called as the voltaic cell, this voltaic cell converts the chemical energy into electrical energy, and that conversion happens spontaneously. That too, the redox reaction. Okay, so that will happen inside this galvanic cell. Is that clear? What is meaning of spontaneity? Spontaneity, when we talk about the spontaneity, here we need to discuss one more important thing. That's a delta Rg. Can someone say what is delta Rg? Which is less than 0. What is delta Rg, Nitya?
So Gibbs free energy.
What is Gibbs free energy? What do you mean by Gibbs free energy?
Sir, I don't know.
Okay, just remember, if delta Rg is less than 0, okay, that means this Gibbs free energy, it is a negative. Yes or no? If it is less than 0, that means it's -1, -2, -3. Yes or no? So this Gibbs free energy, when it is negative, remember, when it is negative, that means the reaction naturally happens without any external input, external energy input. Understood this? What is meaning of delta Rg less than 0? Or when you say the Gibbs free energy which is negative, It means you are performing a reaction without putting or without investing any energy. Okay, without drawing any external source of energy. Is that clear? So the reaction is just happening spontaneously, very naturally. You don't need to invest any amount of energy in this reaction. Is that clear? You don't need to put any heat. You don't need to increase the temperature. You don't need to do anything. It will just randomly happens. Is that clear?
Yes. Yes, sir. Yes, sir.
Sir.
So remember, it is negative. That means reaction occurs naturally without external energy input. So that's what delta G is less than 0 means. Gives free energy when it is negative. Remember, this is very important. So when it is negative means reaction occurs naturally without any external energy input. So that's what the galvanic cell is. So galvanic cell is an electrochemical cell, produce electricity as a result of spontaneous reaction. The spontaneous reaction is nothing but the redox reaction. Remember this. So it's a redox reaction. Okay, and that's happening inside where the delta Rg is 0. That means the Gibbs free energy is negative. That means it indicates reaction occurs naturally without any external energy input. Okay. So how does this electrochemical process will happen? Let's see. Okay, first of all, these are the very basic things you may know, but I again explain everything from the very basic. If you don't know, please learn now itself. Okay, so what happens? The major event that happens in the galvanic cell is chemical energy will be converted into electrical energy. That is what the main thing that happens in the galvanic cell. So chemical energy convert into electrical energy. This is the main thing. Okay, so how does that happen? Let's see. First of all, you need to know few things. Electrodes. What are the two different types of electrodes are there?
Anode and cathode.
Yeah, they are anode, cathode. Banu,
Yes, yes, sir.
tell me what is the charge of anode?
Sir, వినపడుతుందా సార్?
వినిపిస్తుంది Banu. What is the charge of the anode?
Sir, it is plus, sir, and positive.
Hmm?
Sir, it is negative, sir.
ఏంటి బాను ఆన్సర్ మార్చేసావు వెళ్ళలేదనుకున్నావా ముందు పాజిటివ్ అన్నావు కదా
అవును సార్.
తీసుకెళ్ళి ఎల్కేజీలో పడేయాలి సో యానోడ్ ఈజ్ నెగటివ్ cathode is positive. Anion is positive, cation is wait.
Sir, it's opposite, right?
Yeah, cation is positive. Then why the cathode is? One second, guys.
Sir, I guess it's a change in electrochemical cell and electrolytic cell.
Yes.
Yeah, correct. So remember, anode here, it's negative, cathode, it's a positive. Okay, and remember, in anode, I told you it's a redox reaction. What is meaning of redox reaction? The reaction in which the oxidation and reduction happens simultaneously. Remember that. Okay, so where you will be seeing oxidation as well as reduction occurring together at a same time. So that's what the redox reaction means. So where does the oxidation will happen? Where does the reduction happens is at the anode oxidation occurs. Remember, this is very, very important. At the anode oxidation occurs. What is meaning of oxidation, Shikhar?
Sir, addition of oxygen and reduction of hydrogen.
In terms of electrons? Chapra, Google checker.
No, sir, I didn't go there. In terms of electron meaning, which charge will it get?
Nitya, you tell me what is meaning of oxidation?
Sir, oxidation, loss of electrons.
Yeah. Or you can say the removal of the electrons or release of the electrons. Okay. Whereas reduction, that means it will take the electrons. For suppose at the anode, oxidation is happening. That means at the anode, it is releasing the electrons. Those electrons, it will be taken up by the cathode. Is that clear? So remember this. What is galvanic cell? It is the chemical reaction convert into electrical energy, or the chemical energy convert into electrical energy. So that's happening with the help of these electrodes. So it will be having the anode and cathode. Anode is negative charge, cathode is positive charge. Anode, where the oxidation happens. Cathode, where the reduction happens. Okay, remember anode is a negative electrode and cathode is a positive electrode. Clear? So now see how does this electrochemical process occurs. So remember, I told you the spontaneous electron transfer will happen or the spontaneous redox reaction will happen. Okay, in this galvanic cell. So the first thing how it starts is there is a oxidation takes place at the anode. Okay, so the first step that happens is oxidation at anode. So this oxidation at anode, it will helps in release of the electrons. It will helps in release of the electrons. So that's the first thing that will happen. So once that happens, then the second thing that will happen is whatever these electrons that are released, they will flow through the external circuit. Remember? So electrons flow through external circuit. We'll see. I'll show you the cell. Just now understand the concept. Third thing, now they will reach to the cathode. Okay, once they reach to the cathode, there the reduction occurs. So reduction occurs at the cathode. Remember this. Okay, and remember these, whatever the ions are there that are formed, they will move through the salt bridge to maintain the electrical neutrality. That I'll show you later, but just understand this phenomena. So you can see here the oxidation and reduction happening simultaneously. So we call this as redox reaction. Is that clear?
Yes, sir.
So remember, this is a very basic thing. Okay, so electrochemical process means where oxidation happens
Yes.
at anode and reduction occurs at cathode. But this, whatever the electrons released, they will be moving from anode to cathode through the external circuit. So both of these events will be happening simultaneously. So we call it as redox reaction. And this is a spontaneous reaction where you do not require any electrical energy to run this reaction. Clear? So just remember, we'll talk how this ZnSO4 will break down into ions, how this CuSO4 will break down into ions and liberate the electrons. Just you understand this. You can see here, these are the two electrodes, okay? And there will be ZnSO4 solution, CuSO4 solution. And remember, there is a copper rod and there is a zinc rod. Zinc rod in ZnSO4 solution, copper rod in copper sulfate solution, okay? And there will be salt bridge. So through this salt bridge, I told you the ions will move. Yes or no? Okay, so why does these electrons move through the salt bridge? To maintain the electrically neutrality. Okay, that means here to maintain the neutrality, this will be there. Clear?
Yes, sir.
So see here, electrolytics. That's about the galvanic cell. Now let's see about the electrolytic cell. Okay, so electrolytic cell. So what is the difference between the galvanic cell and electrolytic cell is in this electrolytic cell, electrical energy is converted into chemical energy. What happened in the galvanic cell? Chemical energy is converted into electrical energy. Yes or no? Whereas here, electrical energy will be converted into chemical energy. Remember this. So here, electrical energy will be converted to the chemical energy. That's the important thing you need to notice here. So remember, in electrolytic cell, electrical energy will be converted in, sorry, the electrical energy will be converted into chemical energy. So see the definition. An electrolytic cell is an electrochemical cell in which a non-spontaneous reaction is driven by external source of current. So there I said that it is a spontaneous reaction. That means where you do not require any external source of energy. But here it is not a spontaneous, it is a non-spontaneous reaction. That means it's a dependent reaction. It depends on what? It depends on the external energy. That energy you will be supplying like a current. Understood? So you can see the Gibbs energy will be negative or positive in this case. Sharon, you tell me. In this case, the Gibbs energy will be negative or positive.
Positive, sir.
Why?
Because the external source will happen.
Whereas in galvanic cell, it is negative or positive.
Negative, sir.
Shrikar, you tell me, what is this Gibbs energy? Negative means?
Sir, Gibbs energy is negative when it requires without external energy. It doesn't require external energy like heat and all.
Yeah. Okay. So here the external energy means current. Remember that. Okay. Is that clear for everyone? Here the delta, remember here delta Rg should be greater than 0. Remember this. Delta Rg should be greater than 0. Clear?
Yes, sir.
How do you define the electrolytic cell? What is the defining feature of the electrolytic cell? The ability to convert the electrical energy to chemical energy. It is the electrolytic cell. How do you define the galvanic cell? The ability to convert the chemical energy to electrical energy without any spontaneous, without any external source of energy, which is completely spontaneous reaction, where the Gibbs energy should be negative or less than 0. Here, the Gibbs energy should be greater than 0. Clear? So see here, the fundamental thing that's seen in the electrolytic cell is non-spontaneous reaction. Remember this. It is a non-spontaneous reaction, and it depends or it is powered by external source of current. The galvanic cell, you doesn't need any source, but here it is powered by external source of current. Clear? And remember the positive here, it is positive. And what does the positive indicates? The reaction means,
Source of energy is required.
yeah, it is a non-spontaneous, requires external energy input. Remember this. Okay, so it's a non-spontaneous and requires external energy input. Without external input, this reaction will not occur. Okay, and what is the external energy in the sense? You can take a battery or power supply. You need to provide battery or power supply to drive this reaction. And what is the direction of flow? The electrons flows in the direction that forces the non-spontaneous reaction to occur. Okay, that I'll tell you how it will happen. Just now you understand this much. Is this clear? What is the basic difference between electrolytic cell and the galvanic cell?
Yes, sir.
Yes.
Yes, sir.
You can see here, there is an external battery connection is there for the reaction to happen here. Okay, and there is a flow of current, there is a flow of electrons. So just one more thing you need to know. Remember this galvanic and electrolytic cell, both are reverse to each other. Okay, they are reverse of each other. Remember this. And remember, in both the cells, the redox reaction will happen. This is another thing you need to remember. In both type of cells, redox reaction takes place. Redox reactions occurs or takes place or involved. Okay, so remember this. Galvanic cell, where it will convert the chemical energy into electrical energy through spontaneous reaction. And here it is having a negative anode and positive cathode. Electrons flows naturally from anode to cathode without external power supply. Remember this thing. Okay, so this is important. Electrons flows naturally from anode to cathode without external power. That's the galvanic cell. And if we say about the electrolytic cell, so it will convert the electrical energy into chemical energy that happens through non-spontaneous reaction. And it is a having positive anode and negative cathode. Remember here. So in this case, negative anode and positive cathode. In this case, positive anode and negative cathode. Note this point. The one more thing you need to know, it requires the external electrical energy to drive the reaction. Whereas here, it passes naturally without any requirement. Okay, so notice that thing. Clear? Any doubts? So here without external power, here happens with external power or external energy. Okay, here you can say the Gibbs energy, it's a less than zero. Here the Gibbs energy more than zero. That's one more thing you need to notice. Okay, so what is this redox couple? Any redox reaction may be expressed as the difference of two half reactions, which are conceptual reactions showing gain and loss of electrons, such that reduction and oxidation respectively. Simply what this statement says is, actually redox reaction, it's not a complete reaction. I mean, redox reaction, it is nothing but two different reactions, or you can say two half of reactions. If you say the redox reaction is 100%, in that it involves two things. One is 50%, the other one is 50%. Or you can say one is off, the other one is off. What is this of? Oxidation. What is this of? Reduction. That is what he says. And this oxidation and reduction, both together, it's called the redox couple. Okay, the reduced and oxidized species in half reactions form a redox couple. Is that clear? What is meaning of?
So could you repeat? I didn't hear anything, sir.
Yes, sir.
Sir, could you repeat what you told right now? I didn't hear anything.
Why you didn't hear anything?
My mom connected buds and it got connected. I didn't know it.
Okay. So see here, redox couple means it is a two reactions that takes place together. Okay. The first of it's the oxidation process. The other of it's a reduction process. So what happens in the oxidation process? Loss of electrons. Yes or no? From a substance. Second thing, what will at where it will happen? It occurs at the anode. Yes or no? Occurs at anode. In both cells. You take any cell, In both cells, it occurs at anode. And remember, whatever the substance that is reducing, that means whatever the substance that is losing these electrons, those substances are called the reducing agents. Remember here. So what is meaning of reducing agent? The chemical species that is helps in donating the electrons. How it is donating? By losing its electron. Yes or no? So it will reduce the other compound. For suppose there is a and B, A is called as the reducing agent. When you will say, when this reducing agent will make the B to get more number of electrons. How you will get more number of electrons, the B? A will donate those electrons. So that's why A is called the reducing agent and B is where the reduction is happening. Understood? Remember the reducing agent where it will oxidize to make the other compound reduce. Is that clear? This thing, whatever I said, A is called the reducing agent, which it will oxidize. That means it will lose electrons. Those electrons, the B will gain. Once the B gains, the reduction happens in the B. So remember, A is called the reducing agent because it donates the electrons so that the B will obtain those electrons and it will undergo reduction. So A is called as the reducing agent. And B is called as the oxidizing agent. Is this clear? This thing, why it is called the reducing agent and oxidizing
Yes,
agent?
sir.
Yes, sir.
Yes, sir.
So that's about the oxidation process. If you see the same thing about the reduction process, the opposite things will happen. So reduction process. So what happens here? Here loss of electrons, here gain of electrons. Here it occurs at the anode in both the cells. Here it occurs at cathode at both the cells. Cathode in both cells. Here it is acting like a reducing agent. Here it is acting like a oxidizing agent. Here, up to here. Any doubts?
No, sir.
Yes, sir.
No, sir.
So let's see how does the reduction will happen and oxidation will happen. So let's see the reduction and we'll do one thing. Reduction, oxidation. So in this reduction, there will be redox couple. In this oxidation, there will be, one second guys. Here also, as it is undergoing redox reaction, so here also it's a redox couple. So this so what happens now? What is the half reaction that happened here? Here also the half reaction will happen. Let me divide this. So let's see what happens in the left side is half reaction. Why do we say half reaction? Is the M plus E minus, it will convert into the M. Here the M which is in the S state, it will become M plus in the aqueous plus E minus. Here this is aqueous. Remember, always the ionizable state will be present in the liquid state. That's why it is aqueous. So what is this? What is meaning of redox couple? Redox couple is nothing but here it is M plus or M. Here it is M or M plus. That means whatever the M plus is there, it is converting to M. So here M plus and M both are called as the redox couple. Here M is converting into M plus. Here M and M plus, they are called as the redox couple. So these are the redox couple in the reduction. These are the redox couples in the oxidation. So what is this redox couple? First, suppose this is the reduction of reaction where a metal ion in aqueous solution, it is accepting an electron and converting into a solid metal. Remember, this is solid metal. You understood? Let me write in words if you confuse. So this is a reduction half reaction where metal ion, which is nothing but M plus, in aqueous solution accepts electron to form a solid metal. That is this one, reduction half reaction. Whereas the oxidation half reaction, here the same thing. A solid metal loses the electron to form a metal ion in aqueous solution. So here the aqueous solution metal taking up the electron and converting the solid metal. Here the solid metal losing the electron and converting into aqueous metal ion. Okay, so this is the aqueous metal ion, this is a solid metal, this is a ion, this is a metal. So remember here, in oxidation half reaction, solid metal loses electron to form metal ion in aqueous solution. Is that clear? Understood? What is meaning of redox couple? Or what is meaning
Yes,
of
sir.
reduction off reaction
Yes.
and oxidation off reaction? So next one. So electrochemical cell. Electrochemical cell consists of two electrodes or metallic conductors in contact with the electrolyte, which is an ionic conductor, a solution, liquid or solid. What is that? Okay, so remember, so electrodes, there are two electrodes are there, which will serve as the metallic conductors. Remember, so here the electrodes, remember electrodes, they will serve as metallic conductors. That means these are the metals which will conduct the current. Understood? So these electrodes serves as the metallic conductors in a cell. Remember, these electrodes, they will provide the surface so that the electrochemical reaction will occur. So where does the electrochemical reaction is happening? It's happening on the surface of these electrodes. Okay, so remember, you may think that the reaction is happening inside the solution. No, it's not happening in the whatever the liquid present inside the cell. It's happening on the surface of these electrodes. Okay, so remember, these electrodes provide space, or you can say the provide surface where electrochemical reaction takes place. Understood? So one electrode is anode, where the oxidation happening. The other electrode is cathode, where reduction is happening. I told you already. I don't need to here. So this is one thing important for an for electrochemical reaction or electrochemical cell. So remember, when we see about the electrochemical cell, there are two important things. One is the electrode, the other one is the electrolyte or the liquid present in the cell. So this is the importance of the electrode. So serves as a metallic conductor, provides surface for the electrochemical reaction to happen. That's the function of the electrode. Let's see the function of the electrolyte. So next one is the electrolyte. So what does it functions as? It is an ionic conductor. So here the electrode is carrying the electrons. It is taking the electrons. And we know if the electrons are passing through any conductor, that means it is carrying the current. Yes or no? You might have studied in your already the what is that? Electric chapter is over in the physics now. You might have studied there. If the electrons are going through one side, that means the current is passing through the other side. Yes or no?
Yes, sir.
Array, open answer. Otherwise, I'll tell to your Gautam sir. Sir, వాళ్ళు ఏం చెప్పారు మీరు ఎలక్ట్రిక్ కెమిస్ట్రీ అసలు ఏం తెలియట్లేదు అంటాను ఎలక్ట్రిసిటీ. So here One is, this is the one which is passing the electrons so that the current is passing through the wires or passing through the metallic conductor. But whatever the ions that are formed, the metal ions that are formed, now these has to be balanced, right? I told you at the beginning, the metal ions, they have to be neutralized. So here that's happened with the help of electrolyte. So here it is an ionic conductor. Functions as ionic conductor. So it will conduct the ions. So this you can find in three forms. One is the solution. You can find that in liquid form. You can find that in the solid form as well. So what is this solution form? Solution form, you can take the salt water, like NaCl, all those. Liquid form, you can take the molten salts. Solid form, you can take a ceramic materials. So functions as ionic conductor. What does that mean? Functions as ionic conductor. That means it will be helpful for movement of these electrodes. Okay, movement of these ions between the electrodes. Understood? So here it enables ion movement between electrodes. Understood? What is electrochemical cell composed of? It composed of electrodes and electrolyte. This is very basic thing that we are discussing. It's not, we are not even went to depth. I'm just telling what is this electrode, electrolyte, how they serve. If you understand these very basic things, then you can understand the further electrochemistry. If you have a confusion in these basic things, you will not understand that. I'll go into depth into mechanism. This will go to this will go to this. At that time, you will not understand if you don't understand all these things. You might easily know what is electrode, cathode, anode, that's. But what is the function happen at the electrode? What is the function happen at the electrolyte? Is that clear?
Yes, sir.
Yes, yes.
Yeah. So next one, half cell. So a half cell is a setup consisting of the electrode, anode or cathode dipped in its salt solution involving either oxidation or reduction. Okay, so what's happening here? So see here, this half cell, it is a very crucial component for the electrochemical cell. Why? It could be anode or cathode. Okay, the main thing it is, if it is anode or cathode, based on that, the oxidation or reduction, it will happen. Okay, first suppose you see here, this is the half cell. This is the another half cell. So this is the anode half cell. This is the cathode half cell, where the reaction happens. This is the electrode. On the surface of this electrode, the electrochemical reaction happens. On the surface here, the electrochemical reaction happens. Understood? This is the electrolyte. Whatever the liquid, blue liquid or transparent liquid you're seeing, that's electrolyte. These are the electrodes. And remember, this is the half cell. This is the another half cell. In this half cell, one reaction will happen. In this half cell, another reaction will happen. Clear? So for suppose anode, we know that in anode, oxidation happens or reduction? Shrikar, you tell me, at anode, oxidation happens or reduction happens?
Oxidation.
So tell me what happens when oxidation happens here, ZnSO4?
Release of electrons.
Oh, what happens to Zn? It will convert into? I told you na, M will convert into M plus.
Yeah, M plus.
So what happens here? Which one is metal here? So SO4 is a metal, right? Yes or no, Sharon? SO4 is a metal, right?
Zinc.
Yes.
Yes.
Zinc is metal.
Yes. So SO4 is a metal. Super, Sharon. Zinc is a metal. So Zn will convert into Zn plus 2. Here copper is a metal. Cu will take the electrons plus 2e minus. So this is the reduction and this is the oxidation. So this oxidation happen here, this reduction happens here. I told you M M plus, here M plus electron will convert into M. Remember this, I told you.
Yes.
So this is the oxidation happens here at the anode. This is the reduction happens at the cathode. So this is the half cell. This is the another half cell. Clear? So remember this half cell, it is a very, very crucial for the electrochemical cell. Okay. So here where the oxidation or reduction process will happen. So for suppose here oxidation is happening, here the reduction is happening. Clear? So just remember this: anode, half cell, and there is a cathode, half cell. So Shrika, tell me, Banu, you tell me at anode half cell, what is the chemical we saw? Which is the solution we saw at the anode?
ZnSO4, sir.
ZnSO4, where it will undergo oxidation half reaction. Remember this. So ZnSO4, where the Zn will convert into Zn plus 2. Banu, tell me, Zn is solid or Zn plus 2 is solid?
So
Hmm.
Zn, sir.
Yeah, always remember whenever it's present in the form of ions, ions can only form when they dissolve in the water, when they dissolve in the solution, then only you can get the ions. So the Zn is solid, Zn plus 2 is aqueous solution,
Okay.
and plus 2E minus. Here the electrons are liberated. So this is a which reaction? What is the reaction? This one.
Oxidation reaction, sir.
Oxidation of reaction.
Yes, oxidation reaction.
Okay. Next one is cathode. At cathode, what is the thing that we found, Sharan?
CuSO4.
CuSO4, copper sulfate. Okay, so what happens here? What happens here? Cu plus 2, it will, whatever these electrons are there, now these electrons will pass through the electrode and it reaches here. So 2E minus. So this is the aqueous, this is 2E minus, it will convert into the copper solid state. Here, so 2E minus, it converts into Cu. This is a reduction of reaction. Clear? What is anode half cell, cathode half cell? What is meaning of all this? Any
Yes.
doubts?
Yes, sir. No, sir.
Okay. So electrode potential. What is this? So whenever a metal strip is put in the electrolyte, a potential difference is developed between the metal electrode and its ion in solution. Okay. So what happening here? First, suppose you take a metal strip. Okay. You put that metal strip or you immerse that metal strip in the electrolyte solution. Okay. Whatever the solution half cell is there, you put that electrode in that solution. Okay. So when you put that electrode in that solution, in the electrolyte solution, the electrochemical reaction will happen. Either oxidation will happen or reduction will happen. Okay. So this phenomenon, we call it as electrode potential. Understood? So what happened here? Due to this putting here, it will turn into positive ion oxidation or reduction. So it will convert into ionic state. So that's a electrode potential. Okay, so when a metal strips come in contact with an electrolyte, interaction will happen between the metal atoms and ions in the solution. So this metal surface, it will on the electrode where the electrolytic chemical reactions will happen. Okay, all the electrolytes present on this, it will dissolve in this solution. So that leads to the potential development. Okay, so what is this potential development? A potential difference is developed between the metal electrode and its ion in solution. First, suppose So whenever you place that electrode in that solution, there will be certain charge that will be developed between this electrode and the solution. For suppose I got Zn plus 2 here. So this solution containing the ions, and whatever the charge, it will be somewhat neutral charge or negative charge. So this plus 2 charge in the liquid and neutral charge on the electrode, or as it lose the electrons, it will gain some negative charge. So this charge will enable the potential differences. So this potential differences is automatically happened when you put that electrode in the solution. Okay, so that's what we call the potential development means. Understood or not? Or should I explain more detail?
Could you just repeat next time?
Understood.
Okay, do one thing. So here I'm talking about the potential difference. Okay, so that potential difference, how it is created? When I put the metal electrode in the solution, yes or no? First, let me take this is the half cell. In that half cell, I am putting a metal electrode. This is the solution. Okay, so this is the solution, or you can say electrolyte, and this is the electrode. So when I immerse this electrode into this solution, two things will happen. Okay, so what is those? One is the metal atoms on the surface, on this electrode surface, they lose electrons. Understood? So whatever the metal that is present, that metal, for suppose this is a zinc metal. Okay, let's say this is zinc metal. This zinc metal will start losing the electrons and it will turn out to be Zn plus 2. Or it is a magnesium metal. Magnesium metal will lose electrons and it will turn out to be Mg plus 2. Understood? Shrikar?
So,
So metal atom on the surface, okay. So this metal atom surface, it will lose electrons. So those electrons, where it will go? It will go into the solution. Okay. So whatever the electrons that are losing on this metal atom, now they will reach to this solution, this liquid, this electrolyte. Okay. So lose electrons, and these electrons enter into the solution or enter into the electrolyte. So that will form the cations over there. Cations means we know it's a positive charge. Okay, so leave about the charge now. So enter into the solution, then they will form the cations. So that is one event it will happen. Second, what will happen? So whatever the metal ions are present, I told you already there will be ions are present here because they can't simply present. For suppose you have MgSO4 here inside this liquid, you have MgSO4. So when you dissolve that in the water, this MgSO4 will not be remain like MgSO4. It want to break down into Mg plus 2, SO4 2 minus like this. Understood? So whatever the metal ions are there, they will take up these electrons. For suppose here this is the zinc. Zinc is losing the electrons. 2E minus is formed. So those 2E minus will be accepted by this Mg plus 2. Okay, so see here the metal ions in the solution can accept electrons and deposit on the metal surface. So whatever these electrons are taken, they will not keep with them because they don't want to remain like together MgSO4. Or they don't want to be like Mg. They want to be always like Mg plus 2 when they are in liquid. So they will just go to the metal and dump the electrons whichever they gained. Understood? Is this clear?
so
See, right now I'm just not explaining fully how the current is passing. Just I'm breaking down into reduction and oxidation, how the electrode potential is developed. Once all these small bricks you understood, then overall concept I'll explain. Understood?
so
So remember, so whatever the electrode that is present here, for suppose this is a zinc rod. So this zinc rod, or let's say the copper sulfate, it will liberate the electrons. Those electrons will go into the solution that will be uptaken. Okay, so that will discuss later. Just now you understand this much. Clear? Any doubts? Tell me who all understood.
Understood, sir.
Understood, sir.
Understood, sir.
What about you, Banu? You didn't understand?
Understood, sir. I responded.
Okay. Yara Shrika Niga?
Sir, I said understood.
Okay. So that's about the electrode potential. That means the capability of these electrodes to donate the electrons is the electrode potential. The same way, there is an oxidation potential as well. So what is this? It is nothing but the capability to lose electrons, it's the oxidation potential. The capability to gain electrons, it is called as reductional potential. For suppose you have a friend, okay, you ask this friend is having some influence to get the money. If he is having greater potential, he will get great amount of money easily. If he is having less potential, he will get less amount of money with some hard work. The same way here, oxidation potential means, what is meaning of oxidation? Removing of the electrons. How easily you can remove the electrons, that's a oxidation potential. Okay, so remember, greater the oxidation potential, greater the tendency to get oxidized. Understood? That means elements with higher oxidation potential, they can lose electrons very easily. Okay, so remember this. Tendency. So tendency to lose electrons easily, or you can say more readily, and become oxidized is nothing but the oxidation potential. Clear? So see here how this will happen. So Zn, which is a solid state, it will convert into Zn plus 2, which is a aqueous state, plus 2E minus. Just now, this is E Zn or Zn plus 2. So electrode potential, when some metals like copper, Ag means silver, Au ante gold kada? Yeah, Au means gold. So they are into contact with their ions. Okay, so what happened here? So whenever these copper, silver, gold, when they come in contact with their respective ions, like Cu plus 2, Ag plus 2, Au something, okay, when they come in contact with their respective ions, okay, in the solution, then the electrochemical process will happen. That's where the reduction will happen. Okay, so here we are talking about the oxidation. Once the oxidation is happened, then the other thing that should be taken place is reduction. So oxidation happened on the electrodes where it will be breaking down and releasing the electrons. Now these electrons will come into the solution. In that solution, now the reduction should happen. Understood? So the ions in the solution have tendency to get deposited on the metal rod. Reduction will happen. Understood this? So this is what ion metal interaction we call it as. Remember, this is called ion metal interaction. Okay, so what is that means? whatever the metal ions present in the solution, so metal ions which are present in the solution, so they exhibit a natural tendency to deposit those electrons onto the surface of the metal rod. Okay, see, one thing is once the metal is donated the electrons, now these have taken and they converted into some ions, reduced. So once they are reduced, they will not keep with them. The thing they will do is they will carry and they will deposit on here. Okay, so it will be a cyclic process. That's how the cyclic continuous reaction will happen. Okay, so remember, so metal ions present in the solution. So what they will do, exhibit natural tendency to deposit themselves onto surface of metal rod. Understood? So now what happens? So the metal ions in solution will accept electrons and transform into the metal state, and then vice versa. Okay, so reduction process, what happened? Mn plus Ne minus will be converted into M. So you can see here Cu plus 2, which is in aqueous, plus 2E minus will be converted into Cu, where E is equals to Cu plus 2 by Cu. Okay, so remember, the greater the reduction potential, the greater tendency to be reduced. So the potential difference developed between the metal electrode and the solution of its ions at 1 molar concentration and 1 bar pressure at a particular temperature is known as standard electrode potential. Okay, so remember, concentrate here. So what are you saying? First one is talking about the metal electrodes. Okay, so on these metal electrodes where the electrochemical reaction occurs. I'm breaking down this definition into small parts, remember. So remember, metal electrodes where metal chemical reaction occurs. And you will be having, there is an ionic solution as well. And the solution, here the solution means we are talking about the ionic solution. So ionic solution, where the ions are present. So where the metal ions were present. Okay, at 1 molar concentration. Remember, this is at 1 molar concentration. And pressure, how much? Pressure is 1 bar pressure. That means it is maintained at 1 bar pressure. And condition, particular temperature. That means the condition should be specific temperature. It depends. Whatever the chemical solution that you take, based on that, certain temperatures have to be maintained. So here, the specific temperature or particular temperature has to be maintained. So if you maintain all these things, then you call it as the standard electrode potential. Clear? So remember, the potential difference developed between this metal electrode and the ionic solution. So whose metal ions is 1 molar concentration, pressure is 1 bar, condition is specific temperature, then we call it as standard electrode potential. Is that clear? What is meaning of standard electrode potential? Remember, these are very important. 1 bar, 1 molar concentration. Understood? Any
Yes, sir.
doubts?
Understood, sir.
Yes.
Understood, sir.
Tired or should we continue?
Continue, sir.
What about the others?
Continue, sir.
Continue, sir.
Continue, sir.
Good. If someone has said tired, I should be tired. Why you guys should? Next one, electrode reaction. So this is the overall thing. Okay, whatever. See, the same thing you may look like, array, how many times we see the same thing, reduction, oxidation. It's same thing only, just understand. Okay, electrode reaction in standard conditions. So based on the process at the electrodes in an electrochemical cell, oxidation, reduction, anode, cathode. So remember, next one is cell potential. So this cell potential, you can also call it as electromotive force. You might have studied in the physics the EMF. Tell me what is meaning of EMF? Physics. At least tell me what are the units for cell potential or electromotive force. At least tell me what is this. Come on. I'm recording now. I'll send this video to the Gautam sir. What is EMF? Banu, you tell me what is EMF? Gautam sir said Banu is doing really good, the physics.
Yeah. The maximum potential difference between two cells.
What is the use of electropotential? How it will be helpful?
So it determines the voltage.
The units are voltage. What is the use for this electropotential? How can you influence the flow of current with this electric potential or cell potential or electromotive force? Why you call it as motive? What? Why it's called as motive?
Mm.
See, if you are not willing to do something, but your friend will motivate you so much so that you will end up doing that stupid thing. Yes or no? The same way here, current also don't want to go, but you are creating such a motivation that the current want to go very much. How that motivation the current gets? By changing the electric potential. Okay, we'll see. We'll see. I'll tell you. At, okay, just listen. If you don't understand what is electromotive force, listen again. So cell potential, this is also known as the electromotive force, or it is also known as the cell voltage, or it is also known as the cell driving force. Before I explain this, just understand that, for suppose, what should I say? Okay, yeah, think of like this. Think of this. For suppose if water is flowing down the hill, okay, from the top to the bottom. So if I increase the elevation much more, will water move much more faster or less? Or will the water move more or less? So the height difference from year to year. So will it make water to move more or less? Come on, guys, this is a basic thing. Answer. Are
So can you
Shrikar,
repeat the question? My net is not proper.
this is the height, right? I increased the height. This is the downhill. That means the water is moving from height to a low distance. Okay, from a hill to down. Let's think like a waterfall that's moving from hill to down. So if I increase the height, will the water move more or less?
So more, sir.
Yes, it is more. Yes or no? The same way, okay, first I'll just try to first remember electromotive force or it's also called as the cell voltage, or it's also called the cell driving force. Okay, so what is this? This is a very, you can say this is the driving force, or you can say this is a cell potential, where at anode and at, let's say at anode and at cathode. So what happens at anode is, it pushes the electrons away. So pushes electron away. At cathode, what happens? It pulls the electron away. Electron towards cathode. Okay, so see here, someone is trying to throw away, trying to push away, and someone is trying to take that. So both are like coupling with each other, yes or no? So this one want to push away, and this one trying to pull. So this one is pulling, pushing, this one is trying to pulling. Okay, so what happens at the time? Electrons will move easily, or it will oppose to go? Move easily, yes or no? So remember, that's how it's a driving force. Okay, so the cell potential represents where at anode, that means the metal, okay, the electrode, it wants to donate the electrons. Okay, and in the solution, whatever the ions are there, they want to grab those electrons. Okay, here the electrode is trying to give away the electrons, and whatever the solution is there, they are trying to gain those electrons more and more. Now think of like this. Okay, at anode, I have a guy who don't want to give electrons that easily. He's a so miser, like he don't want to give at all. And at cathode, he's a so lazy to take the electrons. Now, the electromotive force will be more or less. For suppose think like this. So there is a very rich person, and he's a very good, kind-hearted. You want to donate the money always. And there is a very poor and very critical situation where you want the money a lot. So much urgency is needed. So in between, the flow of money is more or less. Come on, guys.
More, sir.
More. The same way,
More.
now the rich guy who has more money, but he don't want to donate the money. He's like Ambani. Okay, not like Tata. The other guy, he also have a good amount of money, don't want to take. He's a very self-respective guy. Now the money flow will be the same or less here.
Less, sir.
That's what here electromotive force means. Okay, so here this guy should give out the electrons, and this guy should be eager to take out the electrons. Then the electromotive force will be more. The cell driving force will be more. If the anode is not really want to donate the electrons, and at cathode, if the cathode doesn't want to take the electrons, then the electromotive force decreases. That's what the potential decreases. Understood? So that's what, if I increase the voltage, that means I'm increasing this electromotive force, so that from one potential to other potential, the electrons will try to run. In the other condition, if the voltage difference is less, they don't even want to walk, they travel, or they will just roll. They will sweep through the road. But here, they will rush like anything. You understood? So here the flow of current is more, here the flow of current is less. So that's what, when the potential difference is more, the flow of current is maximum. When the potential difference is less, the flow of electrons is very less. Clear?
Yes.
Sir.
Still you have any doubts in this?
No, sir.
Okay, fine. So remember, what is the importance of this electromotive force? One, it will determine the direction of electron flow. For suppose if he is having more number of electrons, will it try to go this way? No, right? It will go this way itself. So one thing, it will determine the direction. Second thing, it will indicate amount of electrical energy is available. Amount of electrical energy available from chemical reaction. Third thing, this is not needed, just understand, these are all not needed. It will predict where the reaction happens spontaneously or not. Okay, if the flow is, if the electromotive force is too much high, then you don't need to invest any energy to move the electrons from year to year. They will just randomly pass. But if anode and cathode, they are not so willing, then you need to supply from the external source to push the electrons from year to year. Understood? So remember, predicts reaction spontaneous or not. And remember, the units for cell potential is volt. Remember this. This is volt. Clear?
Yes, sir.
Yes, sir.
Yes,
So next one. So this electromotive force, EMF, this is equal to potential difference. Okay, so between the terminals, when no current is passing through circuit. Remember, this is very important. When you are passing through the circuit, the potential difference changes. So you should consider the EMF when the current is not passing. So when current is when no current is passing here. When no current is passing through circuit. This is very important. Okay. So remember, this EMF, it is measured when the circuit is closed. I mean, when the circuit is open, when the current is not flowing. Remember, open circuit means the current is not flowing. Okay. So it is open circuit. And it represents the maximum potential difference between the two, between the two terminals. Okay. And remember, it's also called as the open circuit voltage because you will be measuring at the time of current that is not passing. Okay. So remember, this is also called as open circuit or open circuit voltage. Clear?
yes,
So
Yes.
you can say the electrons flow from I potential, or you can say high electric potential to low electric potential. Clear? So when you have 2 points in the circuit, one point is having more potential, the other point is having less potential. So that's we call it as the electrical pressure. If the potential difference is more, the pressure is more, so there is more willing of electrons to jump from one place to other place. If the willingness is less, then you don't want to go. For suppose you have 2 rooms. In one room, 1,000 people were seated. And in one room, only some 10 or 20 people seated. Now the pressure in this room is very more. So the people want to move from A room to B room. Now take like this. Both are having 100. So will they show to move from one to other room? No. So here the willingness is not there. Here the willingness is so much is there. So this is the electric potential here is maximum. Here the electric potential is minimum. Clear? So that's you can also call it as the potential pressure, or you can say the electrical pressure, which will be guiding force. So let's see what is the relation between delta RG and E cell. So the maximum non-expansion electric work that a system, the cell can do is equal to decrease in Gibbs free energy. So what is that? First, suppose let me give an equation. W E max, this will be equal to delta G difference. Okay, so what is this? Here it says that maximum non-expansion electric work. What does that mean? Uh, mhm. You see here, so when we talk about a cell, okay, it can produce the electric work, yes or no? And that work is a non-expansion. because it doesn't involve any change in the volume. For suppose you take a battery and you are using it, the volume doesn't change. Okay, and the cell will be having maximum limit how much electric work that a cell can do. For suppose every cell there will be maximum limit is there. So this can supply this much of power. The other cell can supply this much of power, and their volumes are also like will not change. Okay, so that we call it as maximum non-expansion work. Understood? Maximum means the maximum amount of electric work that a cell can do, and non-expansion means the cell which will not expand, which will not change in volume. So that kind of cell, how much work it is doing, okay, that will be equal to decrease in the Gibbs free energy. Is that clear? Understood? What is meaning of this? Yes or no?
Yes, sir.
Yes, sir.
So remember, non-expansion means not change or doesn't change in volume. And maximum work. So what is meaning of maximum work means how much electric work it can do is a maximum work. So that's together we call it as maximum non-expansion electric work that a system can do is equals to decrease in the Gibbs free energy. Okay, so remember this delta G is nothing but Gibbs energy of the cell reaction. Okay, so we'll see what is that. Tell me what is delta G? We already discussed what is delta G. Gibbs. It is called the Gibbs free energy. If Gibbs free energy is less than negative, what should I say?
Spontaneous.
Huh? Spontaneous, yeah. Okay, so remember the negative sign of delta G, it will increase the energy that energy is released by the cell. Okay, whereas if you take the delta G is positive, that means it needs to be supplied. Okay, so remember the more negative the Gibbs free energy is, the more electric work the cell can potentially perform. Understood? So remember this thing, this is very important. The more negative delta G for a cell reaction is, or you can say delta G is, the more electrical work, or you can say the more power it can supply. Okay, the more electrical work cell can perform, potentially perform. Okay, so that's how using this one only they will design all these electric cars. Now, if you see this electric car, it is having less capability of battery compared to the other one. So this cost is less. The other one is having super capability. So the cost will be higher. So how you will tell that? How you will design that? Whether this one is having more or less, that they will be calculated by using this Gibbs energy. Okay, so they will calculate these batteries and fuel cells. They will design with the help of this Gibbs energy. Understand that? So maximum electric work obtained from a cell is delta Rg. Okay, where delta Rg is equals to minus Q into V, that is equals to minus NFE. So what is meaning of Q here? So Gibbs free energy you can define like it is the product of negative charge into potential difference. Remember, so here Q means charge, V means potential difference. So how much charge is there and how much potential difference is there? If the charge is more, the battery is more powerful. Yes or no? If some battery can hold more amount of charge, let's say we are saying for mobile, I have a 5000 mAh, I have a 6000 mAh. That means it is having more capability, yes or no? The same way, if it is also having more potential difference, that means it is ready to give more amount of current. Okay. Sometimes what happens, we'll say that when the current is not coming into the house and the lights are dim, what we'll say, the voltage is down. Why? That means whatever the current the officers are sending, it's more only. But the current at your end is, and the current at their terminal, the potential difference is very less. So the wires are losing so much of power. For suppose, I'll tell you one thing. So there is a one pole, there is another pole. Here the wires are there. Okay. Now if I transmit the power from ear to ear, what happens? Certain amount of current will be lost because it is passing through the wire. When it is passing through the wire, there will be offering of resistance. Yes or no? So when the resistance is there, the electrons cannot move very easily, so they will collide with each other. So there is a loss of current. So what they did now, they increased the potential in this pole and they decreased the potential here. So now what happens? Even if you send the less amount of current, it will go to the maximum level without any waste. Understood? So the more the potential difference you have, the more the Gibbs energy you will be having. The more the charge you have, the more the Gibbs free energy you will be having. The better the battery performance is. Understood? Any doubts?
No, sir.
You guys are getting anything or you feeling bored? Come on, give me honest reply. I can reduce the syllabus. I mean, I can reduce the depth of explanation if you feel bored.
No, sir.
Only Banu is feeling interested.
No, sir, it's interesting.
చెప్పడానికి ఏదో
No, sir.
పోయగలం అడిగితే చెప్పా శరణ్ అయితే అసలు ఇంట్రెస్ట్ లేదనుకుంటా
No, sir.
ఎప్పుడు క్లాస్ అయిపోద్దని వెయిట్ చేస్తుంది అనుకుంటా శరణ్ ఎస్ శరణ్
No, sir.
And remember, this is equals to minus NFE. N means here number of moles of electrons. Number of moles of electrons. Okay. E means electrode potential. Or you can say cell EMF. And what else? F. F is Faraday's constant. Okay. Delta RG means change in Gibbs energy. For half cell. Or you can take the cell also. So F value is 96,500 coulombs per mole. Remember that. And finally, this is the end. So by knowing this delta G, delta RG at a specified composition, the cell EMF at the composition can be stated. Okay. So based on that, you can tell whether the reaction will happen spontaneously or non-spontaneously. Spontaneous reaction, how do we categorize that? When the Gibbs energy is less than 0. So negative Gibbs free energy. That's a result in E cell which is greater than 0. Or you can say this is positive cell potential. Or you can say the cell is so motivated to do its own performance. Here, E cell is less than 0. That means the cell is not so motivated. So what you need to do, you need to give external push. So require external energy input. You can say this is negative electrode potential, negative cell potential. So here, spontaneous, without energy, without external energy. So that's it for today. Any doubts?
No, sir.
No, sir.
You guys feeling interested or boring? Tell me. Based on that, next class, I'll decide how much I should teach.
It
Okay,
was
tell me.
interesting.
Banu, you tell me, what about you?